Section 3.5, Writing and Graphing Linear Equations. We are going to write equations of linear functions in slope-intercept form. We're also going to be working with standard form, and we're going to be talking about x and y intercepts and graphing lines as well. So this should be fairly familiar for you from intermediate algebra. So hopefully this will come back pretty quick, but there is a lot to cover. So linear functions, probably most of you are the most familiar with slope-intercept form, y equals mx plus b, where m is your slope and b is your y-intercept. But we did also work with standard form, which is ax plus by equals c, and that can be really helpful for finding the x and y intercepts and graphing something that way. Point slope form, some of you may have covered this, and this is if you are given a point and the slope, then you can drop the point in for x1 and y1, and you can drop your slope in for m, and that makes a very convenient form. I'm not going to specifically talk about point slope form, but if you remember it, you certainly can use it. So when you write an equation of a line in slope-intercept form, you'll need the slope and you'll need the y-intercept. And once you have the slope, like m equals -2, and you know your y-intercept is 10, so b equals 10, you literally just write the equation y equals m, which is -2x, plus b. And it's really that easy. But of course, we're not always just given those things. We might need to find them. Like in this example, we are given 2 points on the line. And if you're given 2 points, whether it's graphed or not, then you can use the slope formula to find the slope. So y2 minus y1 over x2 minus x1 gives us -2 minus 4 over 3 minus 0, which gives us -6 over 3, or -2. Now, of course, I probably just could have counted, okay, but we're just showing you the process in case you're just literally given the 2 ordered pairs and you don't have it on a graph. It's not very convenient to do. So once you find the slope, you put it in y equals mx plus b, but now you need to take one of the points that you're given, whichever one, and you have to plug the x value in for x. So I will put -2 times 0 plus b equals my y value of 4. So really this just gives me b equals 4. And maybe some of you actually noticed that this is in fact the y-intercept. But I wanted to show you the process anyway. So now that I have my slope and my y-intercept, I can write the equation y equals -2x plus 4. And here's another one where you are given, and if you're being smart about this, you could probably notice that, again, this is the y-intercept. So find your slope, find your y-intercept by either plugging the point in to verify, or you can certainly count the slope and then go back and check the notes to see if you got it right. I'm not going to work this one out in the video. I'll let you try that one on your own. So now let's work on writing an equation of lines that are either parallel or perpendicular to a given line. This says write an equation of a line passing through the point 2, -3 that is parallel to the line with this given equation. So I know that my slope of this given line is 6 because it's in slope-intercept form. So the parallel slope will also be 6 because parallel lines have the same slope. So right now, I know my slope is 6. I don't know my y-intercept. So what I do to find the y-intercept is I take the point that I'm given and I plug it into y equals mx plus b, so 6x plus b. Now I take my ordered pair, I put the -3 in for y, I put the 2 in for x, and that gives me 12. So now I get b equals -15. So now I have what I need to write the equation y equals 6x minus 15. So again, the only thing you're ever going to use if you're writing equations of lines that are parallel or perpendicular to a given line, the only thing you use from the given line is the slope. You don't use any of the other numbers. So let's try another one. Now we're going to write an equation of a line that goes through this point that is perpendicular to this given line. So again, the slope of this line, it's in slope-intercept form, is -1/2. So my perpendicular slope has to be the opposite reciprocal, so that makes it positive 2/1. So now I'm going to take my slope. I know that my slope of this line that I'm writing is going to be 2, and I need to find the y-intercept again. So I take the x and y from the given point that it's going to go through, and I plug it in. So y equals 2x plus b. Now take your ordered pair, plug in the x and y value. So b then is equal to -10. So b is -10. So now I can write the equation y equals 2x minus 10. All right. So what about these horizontal and vertical lines? So if you look at this particular example, you're still going through a point, but it's parallel to y equals 5. What kind of line is y equals 5? Well, if you remember, y equals line are going to be horizontal lines going through the y-axis at that value. So if I just graph the line y equals 5, that goes through right here at 5, and that's the equation of the line y equals 5. But I want to write the equation of the line that's parallel to this. The given line, the slope of the given line is 0. So the line parallel, the slope will also be 0. So we know it's also going to be another horizontal line. Well, it's going through the point 9, -3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. It's going through this point. Well, if it's going through that point and it has to be parallel and also horizontal, it's going through the y-axis here at 3. So the equation of your line would be y equals -3. And that is your answer. Okay? So what if you wanted, this wasn't in the example, but what if you wanted a line that was perpendicular? Now my slope is going to be undefined, and it's going to look like this. And if it's going through that point right here, that would be the equation of the line x equals 9. That question wasn't asked, but I think it's worth doing. So let's look at an application here. The graph below describes the membership cost for a country club over the course of 3 months. Write the equation of the line, and what does the slope mean? Well, if I write the equation of the line, I'm going to want to find the slope and the y-intercept. Well, here's 2 points on my line, and I can use the slope formula y2 minus y1 over x2 minus x1. Or I can notice that I'm going up 2 spaces, but those 2 spaces represent 500 each. So it's actually 1,000 over, and I am going over from 3 to 5, so 2, so that gives me 500. And my y-intercept, I can take that value and plug it in with my one of those 2 ordered pairs, and that would verify. But if you look down here, this slope right here is our y-intercept, or that value of 5,000 is our y-intercept. And we could verify that by plugging in one of these points right here in with our slope to double check. But for time's sake, I'm not going to do that. And so the equation of our line becomes y equals 500x plus 5,000. And it asks, what does the slope mean? What the slope means is your cost is rising $1,000 for every 2 months. So that means that your slope, your cost, is going up $500 each month for the membership. So that really means your membership costs $500 a month, and your initial fee to join this golf country club is actually $5,000. It's kind of expensive. So let's talk about standard form. Standard form is ax plus by equals c. And that can be really helpful if you're looking at the y-intercepts. Because the x and y intercepts, you can find them by plugging in. So to find the x and y intercepts, you can plug 0 in for x, and that will give you the y-intercept because it's the value of y when x equals 0. You can plug 0 in for y, and that will give you your x-intercept. And so that if you have 2 points, that's easy enough to graph. Any 2 points will make a line. So here's a little refresher on logic chains. If you have both the x and y intercepts, then you have 2 points. If you have 2 points, then you can graph a line. So if you have both the x and y intercepts, then you can graph a line. So let's give that a try. So here is an example in standard form. So if I put 0 in for x, that's going to give me the y-intercepts, and that would give me 2 times 0 minus 3y equals negative 12, or negative 3y equals negative 12, so y equals 4. So I know that my y-intercept is 4, or the ordered pair 0, 4. Now I can do the same thing to find the x-intercept. I am going to put 0 in for y and find the x value. So now I would have 2 times x minus 3 times 0 equals negative 12. And that gives you 2x equals negative 12, so x equals negative 6. So that means my ordered pair, negative 6, 0, is on my line. Right here. So now I have 2 points, and I can draw the line between any 2 points. So standard form can be really a convenient, easy way to graph. Here's another one that you could do standard form, and honestly, sometimes it's just really easy. If you just go ahead and put 0 in for x, you're going to have, that's just going to cancel out, and you're going to get y equals 2. When you put 0 in for y, 4x plus 0 equals 2. Again, this is just sort of like covered up, and you'll just have 4x equals 2. So you can kind of sort of just like cover this up, cross this out right here, and that gives you 4x equals 2. So your value here for x is 1/2. 2 over 4, so my x equals 1/2. So now I could plot those points, and yeah, that's a little tough to plot, but I can do it. There's 1/2, and now I can plot my y value of 2, and I can graph my line. So this is the process. If it specifically asks you to use x and y intercepts, then make sure you practice that way. But I would try each of these problems, just whichever seems to make the most sense. If you're going to use the slope-intercept form, like on this example, what you will need to do is solve it for y. And sometimes it's just easier to solve for y than even using the x-intercepts. This becomes y equals negative 3x plus 5. So to graph this line, I go to 5. And then I go down 3, right 1, down 3, right 1 for my rise over run. So it really just depends sort of on your preference or what makes the most sense in that problem. So you can try this one, whichever method you prefer, and then you can check back to the notes for the answer. And then we just have one more problem that's a little bit more challenging. It says, what are the x and y intercepts of a line that passes through these 2 points? Well, I know that I can find the slope here. So I can do y2 minus y1 over x2 minus x1. So I'm going to go 1 minus 3 over 2 minus negative 2, which gives me negative 2 over, and subtracting a negative turns positive. So my slope is negative 1/2. So now I can take and put this into y equals mx plus b. and I pick one of the 2 points. It doesn't matter which point you pick. I usually just pick one that seems to have the smallest numbers or the fewest negatives. So now 1 equals negative 1/2 times x plus b. So negative 1/2 times 2 would give you negative 2 over 2, or 1. Give you negative 1. Now when I add, I get b equals 2. So now I can write the equation. I know my y-intercept. So it says find the x and y-intercepts. So the y-intercept I just found, and that is 2. Now I need to find the x-intercept. So how do I do that? Well, one way you could do it is you could write the equation y equals negative 1/2 x plus 2. There's your y-intercept. And now, remember, your x-intercept is the value of x when y equals 0. So you can put 0 in for y and solve this. So I'm going to subtract 2 from each side. And now I'm going to divide by negative 1/2. So when I take negative 2 and I divide it by negative 1/2, of course that's going to give me a positive, and that would give me 4. So my x-intercept is 4. So this is the end of lesson 3.5.